Okay, for all those who don't know, this young man here, this is Eli Golding, self-titled professional meme generator here at Quality Bath. Today he's going to be giving us a quick a talk, so we say, on performance matters. If you didn't read the whatever it is, it's going to be about web performance, specifically targeting browsers and how to get your site rendered as quick as possible. I think you'll all learn something from it. Enjoy.
So, okay, thank you everyone for coming. Like I said, Eli Golding. I have the privilege of working here at Quality Bath. A wonderful place to work because you get to use amazing technology to sell very, very expensive toilets. It's a weird place to work because eventually, like, you reach a point where you can't go to the bathroom anymore without noticing what company the toilet is. It's not a joke. But whatever. And we're going to talk about performance. Okay, there will be no foolish wand waving or silly incantations in this class. Web performance is a journey, and it is, and there is no silver bullet, and there's no magic, and it takes a very long time. And what we're going to do tonight over here, instead of me doing you a disservice of giving like a lot of pieces, a lot of rules, like we say, and pieces of advice, we're going to try to understand the foundations of what all things web performance related are built upon, and that we could develop an intuition to what all these performance techniques do for us, basically. So we're going to start talking about time and perception, the way humans perceive time as opposed to how long time actually is. And we're going to go back all the way to Alice in Wonderland, where Alice asked the white cat, "How long is forever?" And the white cat and the white rabbit, thank you. And the white rabbit said, "Has she? Sometimes just 1 second. Sometimes just 1 second would seem like forever." And then we went a few years later, and there was a study done by, I forgot his name, back in the 60s, where it said user time and perception, basically anything that happens from 0 to 1 milliseconds feels constant flow. 100 to 300, a human already perceives a slight delay. Already after 300 milliseconds, completely loss of task focus and a perceptible delay, more than 1 second mental context switch, and more than 10 seconds, our users will absolutely leave our site, basically. And if you want to know why this matters, this is actually a report done by Google, pretty recently, right? That's right. Still a few more weeks till 2017. Basically, when your page load time goes up from 1 second to 3 seconds, the probability of your bounce means like a user coming to your site and just leaving right away, increases 32%. 5 seconds, 90%, 6 seconds, 106%. Wow, yeah, these are big numbers, and it really matters. Etsy, they added just 160 kilobytes, I think, to their page weight, and their conversion rate went down like 12%, something like that. Crazy numbers. They can afford to do those tests, we can't. But basically, we're just, we're a bunch of fish, okay? Fine. So the question we have to ask each other is, can we render in less than 1 second? Quite an endeavor. Ambitious endeavor, thank you. So we're going to try to figure that out. So this is a slide that I stole from Eli Golding from Google. It's basically web performance in one slide. So we have the network, where all our stuff come from, because we're on the internet, and the internet is the network. We have to get our HTML and CSS down to the client, also our JavaScript. We have to build the DOM and CSS, which builds render tree, layout, paint, the wire, understand all this stuff, we'll get to it. But basically, there's really 3 parts to it. There's the network, there's getting the stuff down into the browser, there's the critical rendering path, which is basically the path that it takes to actually get something onto the screen, and then in-app performance, which is basically rinse and repeat of the critical rendering path over here, right? The JavaScript will make a change to the DOM and the CSS DOM, and we start the process again. So this is basically all of the 3 parts of web performance that we're going to talk about. So we're going to start talking about the network. Obviously, the faster we get our data down to the client, the faster we can render our page to the screen. Right? We're trying to get pixels to the glass in 1 second, right? For that perceived performance, for the user perception. I think that it's going fast, even though 1 second still might not be usable after 1 second. But as long as they can see something, that's okay. But in order to optimize the network, we need to learn about the network. I'm sorry, I know we're web developers and we're not IT geeks, and we don't like talking about the network, but we have to talk about the network anyways. So bear with me, but it's actually pretty fast. So when we talk about the network, we usually talk about 3 things: bandwidth, throughput, I'm not sure, like us, me and TK, and latency. Oh my. Okay, so we start with talking about bandwidth. Something's going on over here. So when we talk about bandwidth, we're going to go back to the olden days. I don't know how many people remember this guy over here. This is actually my first modem. A long time ago, right? Where you had to fight, someone was using the phone, you had to make them hang up, and then someone would pick up the middle shot. Okay? And yeah, so that was the olden days, right? Not too long ago. So that was 56K, 56 kilobits a second. Anyone here not remember that sound? Okay, because when I did this for the
Not
girls,
that old.
like a few girls that what?
Not that
I
old.
thought I did an in-house training, and like two of the girls were looking at me like, what is that noise? Okay, so bandwidth. Bandwidth is the maximum amount of data that can be sent through a network channel at any given period of time, measured in megabits per second, not megabytes. Your ISPs like to make you think that they're giving you a lot of things, but they're really not. They just like stealing from you and raising your prices every year, whatever. So it's megabits per second, and the metaphor usually we give is like the maximum amount of data. So how many lanes are in the highway? What's the maximum amount of cars that we can pack into the airports? That's bandwidth. Throughput, very much related to that, is basically the throughput is that amount of data that's actually moves from one point to another in a given amount of time, right? So you can have a lot of bandwidth, but your throughput might not be. You can have 5 megabits a second, but you're probably not getting 5 megabits a second. Your actual throughput is going to be significantly less than that, and we'll see why. So basically, how many cars are actually on the highway at a given time? So we have a lot of lanes, but not all of them are being used. So that's throughput. Latency is the amount of time it takes for a packet to reach a destination and back, measured in milliseconds. Okay, so this is something that's very hard to measure because it's very there's so many different factors involved. The first one obviously is going to be what type of internet connection you have. If you're on fiber optic, you're on cable DSL or mobile or Wi-Fi, all of that will create a different amount of latency. But on FiOS, which we have over here, we probably have around 18 milliseconds to get to ISP and back. Cable is more in the 40s, whatever. Mobile, this guy. So this is 4G LTE, so probably we have about 100 milliseconds to get to the tower and back. That's if I already have a connection to the tower and the tower wants to talk to me. Mobile, cellular technology is pretty complex. I'm not going to go into it because I don't understand it. But basically, on 3G, you're talking about a few hundred milliseconds for a packet. One packet is 1.4 kilobytes. Not a lot of data at all. So it takes it will take you on a 3G network, on your average 3G network, 1.4 kilobytes of data will take 200 milliseconds to go back and forth. The average page weight of an average website on the internet today is about 3 megabytes. Do the math, but we'll see exactly how to do the math. But it can really cost us. So latency is how much time, the actual time, not how much data, but how long it will take for one little itty bitty piece of data to get there and back. So I know what you're all thinking. Okay, but just like why do we have to worry about this stuff? Because we have a lot of latency. We have a lot of bandwidth, right? So just give us more bandwidth, and as the global network gets better, and we'll lay more wires and better wires and whatever. At least where I live in Rancho, we'll never get better wires, but whatever. Most of the places, most of Lakewood has FiOS, I think. Just give us more bandwidth, right? And then we don't really have to worry about the whole network aspect of our performance. So why am I even up here talking? So what if I told you that more bandwidth really doesn't matter? When it comes to web performance, bandwidth plays a very, very, very small role in how fast your website will actually load. This is very telling. A study that was done by this dude over here that created the Speedy Protocol, which is predecessor to HTTP2, which I hope everyone's slowly learning about migrating to, please. So bandwidth versus latency. Basically, he took a page, whatever. I don't know how long the wait was, but a constant latency, and he doubled the bandwidth over time to see what the effect on the page load will be. And he noticed that at the beginning, when he went from 1 megabit, it went twice as fast as I think. But then, as he kept adding more and more and more, eventually, it just stopped. The page couldn't get any faster. However, but by over here, where he just had the same amount of bandwidth, but decreased the latency, he had this linear downward, whatever you want to call it. I don't But basically, it just got faster and faster over time. Started with 200 milliseconds and took off 20 milliseconds off the latency each time. So you see that really, you see obviously over here that decreasing latency, which is something that's almost impossible to do. We're going to have to figure out how to do it. That's what really matters when it comes to web performance. Latency, not bandwidth, is the main bottleneck when it comes to the network. And this is what I want you to take away from this, this section over here. Latency, not bandwidth, is the main bottleneck when it comes to the network. And the question is, why? Right? Why? What is this phenomenon that causes that? And the answer, then we have to go a drop deeper into TCP. TCP, does everyone know what TCP is? TCP is the protocol that HTTP rests on, TCP IP, whatever. TCP is the actual transfer, the actual transmission control protocol. Actually, the protocol that actually controls the packets going back and forth. So, anyone from Montreal? I guess not. Okay, whatever. There's always traffic, always congestion over here carrying. I didn't take this picture. It's actually on Wikipedia's page on congestion control. So I guess you couldn't find more congested spot. But basically, the client and server, when they talk to each other, they have a problem, right? Because you can have as much bandwidth as you want, but the server has no idea how much bandwidth you have. And so it has to serve you 3 megabytes, and it has no idea how much bandwidth you have. And if it just sends you everything all at once, then you're going to have a problem, right? Packet loss is a big problem. It's not a big problem, but it happens. And if the transfer protocol is not managing that properly, you could end up getting big pileups like we have over here. So, in order to fix this problem, TCP does what's called, TCP actually has what's called the TCP Slow Start. My slides are out of order. Not really out of order. So the first part of so it has TCP has a whole mechanism of controlling figuring out how much bandwidth it could send. So how does a client and server talk to each other? So this diagram I stole from Eli Golding's book, High Performance Browser Networking. Awesome book we have on the shelf over there. It's free. You can read it free online. Everybody has to read it. But basically, he goes through everything I'm talking about in the first two. He goes through in the first two chapters in great detail, and you can learn a lot. So over here, our round trip time is 28 milliseconds. That's our latency. Our latency is 28. Got pretty good connection over here. So the beginning, when a client starts talking to a receiver over on a TCP connection, the first thing it does is it sends one packet. This is called the Way Handshake. It sends a packet, SYN. The server responds with the SYN packet. Ignore the whole random number or whatever. Basically, and then the client will respond with an ACK packet, and then and only then will it request the application data. So just creating this connection to make a request to the server to give you something is already 3 round trips. So here 28. So that's 84 milliseconds on a 28 just to make the request. On a 80, the server didn't get the request until 84 milliseconds later. This is on 28 milliseconds, which is pretty decent latency. On a 3G connection, you'll have 200 milliseconds. Do the math. I can't do that. Whatever. 300 milliseconds. 300 milliseconds until the server actually gets the original request. Okay. So it's a long time. That could be a very long time. 300 milliseconds. If you go back to the other. Okay, I don't want it to make noise again. But whatever it is, 300 milliseconds is you lost your your user already lost focus. Okay, now I skipped a step over here. There's DNS resolution and TLS, which we're not going to talk about, but that's another 4 round trips. Okay, so DNS is 1 round trip, TLS is 3 round trips. TCP handshake is 1 round trip, so that's 5 round trips just to request from the server your application data. On a slow 3G network, you already lost your second. Figure out what to do about it. So first it makes the handshake, then it starts something called the TCP Slow Start. Like I said before, it has no idea how much bandwidth it is. So it starts off with a congestion window. See, congestion window size. Congestion window size is basically how many packets it's willing to send at a given time, right? So on the old servers, on the old Linux servers, the default was 4. Now recently they upped it to 10. So please, if anyone's on an old hosting, old host, try to make sure that your kernel's up to date because that's very. It could be that your initial congestion window is only 4 packets. So 10 packets is 14 kilobytes. 14 kilobytes, it will send it, And then the client, so the server will send it after those 4 handshakes if you're on TLS, if you're on TLS, right? It's no excuse anymore, let's encrypt, it's free. So 10, and the client responds, I got it. So here's one round trip, this is 58, we're on different, I don't know why it keeps changing the latency, but here we have one round trip is going to be 58 milliseconds. The client says, oh, you got 10, great, I'm going to double it, and I'll send you 20. 56, what is it? What?
That's 56.
Whatever it is. Yeah.
It's 28 times 3.
What is it?
It's 28 times 3.
Whatever, okay, it doesn't matter. The point is, and then it will keep doubling it, and doubling and doubling it. So first it will send 10 packets, 14 kilobytes, then it will send 28, and then it will send 28 times 2, then it will send 160, and it will keep growing that window size until we got a packet loss. And then we'll move, right, so we have this exponential growth, we'll keep doubling until it loses the packet where the client says, okay, this is what I got, and the server said, wait, I know that I sent you more than that. There was not enough bandwidth for me to send you that information. So then it goes into a whole new algorithm with congestion avoidance and basically uses a different algorithm to sort of try to figure out how many lanes there are on your highway, and that's that. So this is like a whole diagram, basically a 3-way handshake. The server will process it, and then it will send 10, and the client will say, I got it. Act is acknowledged, I think. Then the server will say, oh, you got it? Awesome. I'm going to send you 10, 20. And say, I got 20. And then it'll say it only has 15 left, because it was trying to send 28 bytes, whatever. That's all it had left, so it sent 15, acknowledge 58, and that's the end. So this 28 milliseconds latency took about 264 milliseconds for the client to get that amount of data. We have 4 round trips plus DNS and TLS. It's another 4, so that's 8 round trips. On a mobile connection with 200 milliseconds latency, you have many round trips, and it will take you almost 2 seconds to load. Not a lot of data. It's less than a megabyte data, right? So if you have a website that's serving 3 megabytes, because that's the average according to the HTTP archive, whatever, around 3 megabytes is your average site. On a mobile, if given that this whole dance, TCP Slow Start, you're going to have a lot of stuffs. So to sum it up, we have the TCP 3-way handshake. That's one full round trip of latency. TCP Slow Start is applied to every new connection, very important. So we have the flow and congestion control, which regulates the throughput. So you have bandwidth, but the TCP is going to control how much data is actually going back and forth. And throughput, like we said, it's regulated by the current congestion side, which is going to grow slowly. So, like we said, latency, not bandwidth, is the main bottleneck in the Latency network because you can have as much bandwidth as you want. Every single TCP connection is going to go onto that process. So latency, the more latency you have, the longer it will take. So it's a problem. So what can we do about it? Well, we can't remove latency. We're bound by physics, right? Latency has to do with how fast light can travel over a wire, or how based on radio radio waves and stuff like that. So there's really nothing we can do about it. So everyone can go home. We try to avoid it. We can try to architect our sites in a way that we can avoid this problem because this is huge. So what can we do? Ways to avoid latency. Use a content delivery network to move your content closer to the user. Anyone not know what a CDN is? All right, CDN is basically, okay, thank you. CDN is basically a global network of servers. They call them edge servers, which are physically, they're distributed around the globe, and they basically will cache your site, or either whatever different ways of how you get CDNs to cache your site. And then you're physically closer. You're right, like we said, avoiding it. Right, we basically made the wire shorter. Instead of going to a server, if you're here in New York, instead of going to a server in Virginia, you're going to an edge server that's close to you. So that's the first piece of advice. Compression, so important, right? Use compression. Why? Because then you're sending less data. Less data means less round trips. It sounds obvious, but it's and including compression is also minification. It's also minification. Now compression, right? So gzip or deflate if you're crazy, whatever. Brotli is the new kid on the block. You should look into it. What?
Was that?
Brotli. What? Braley, it's the name of some Swiss pastry or something like that. Why why that compression algorithm is called Braley, I don't know. There's another one also called Zopfli or something, yeah? Whatever, I don't know. I'm not sure who does these things, but whatever it is. What is it?
Typically your CDN.
Yeah, so you're right. So these two things work together because your CDN a lot of times will take care of your compression. It will help you with your compression, to say the least. So CDNs are very important. We use Cloudflare, Cloudflare plus CloudFront, whatever. Yeah, we doubled it. But there's Akamai and Fastly and all the guys. Look into it. It's very important. And make sure you're compressing properly. And compression is minification, obfuscation, and all the other stuff that you do with the actual code as you build it to ship it off to the next. Caching. You got aggressive caching, right? Because the fastest request is the one that's not made. If we're trying to get rid of these round trips, just get rid of them. Just don't do that. So caching is not easy. And there's many different types of caching. Right, there's your browser does some caching for you, but basically your application you have to be sending the right headers in order to have all the different layers cached properly. And use either have all your assets have unique names and cache them for a year, or there's e-tags, whatever. There's a lot of different ways to do a lot of different ways to configure your caching, but make sure you're doing it because otherwise you're just throwing money out the window. Reuse TCP connections. How do you reuse TCP connections? So we're also getting into configure. These are all things that you do on your server. Basically, there's keep alive, pipelining, HTTP2. Right? Look into it, see if it can work for you. HTTP2 is not a silver bullet, but it does cool stuff. With multiplexing over connections and stuff like that. Reuse TCP connections. Reuse DNS connections. Stop sharding, right? Sharding was what they in the olden days, because of I guess a deficiency or whatever in HTTP that the HTTP protocol could only handle like 6 connections at a time, so you used to spread it over, used to spread your assets over different servers, but that means you have 3 different servers. Every server is doing another DNS. Your client has to do another DNS lookup for every single server. So that could cause you a problem. Sometimes you need it, whatever, you have to play with it. Like I said, there's no silver bullet, and you just really have to just iterate a lot. And like I said, it's a journey.
Does the CDN handle that too?
I'm sorry?
Does the CDN handle that too?
The CDN, no. I mean, your client has to make a connection to if everything's on the CDN and you're only connecting to that one thing, so then your client will only make one DNS connection. If that answers your question, the CDN is not gonna meaning you could put it. I'm sorry.
On a static website, Cloudflare will do it for you.
Right.
Well, okay.
But if you have an application that has to go through both places, it has to pull stuff from your server.
Right.
The CDN's not going to cover it.
So you're saying CloudFront will actually do the connection for you beforehand
if you have a static website.
If you have a
so it does
static
it for
website.
you.
Okay.
If you have a static
Yeah.
website.
There's a few more things I left out over here. Redirects. Redirects are a killer, right? You're coming to, someone comes to myawesomewebsite.com.org, whatever, and you want to redirect them to www or whatever you want to redirect them. That redirection is we start the whole process again: DNS, DLS, Way Handshake, that whole thing again. Redirects are bad. Don't do them. Any other ways to avoid latency? I don't think so. Any other questions before we move on to?
When you say caching, are you specifically talking about static assets or data like on a server as well?
Both. Here I'm talking about static assets because we're talking about the trips to and from the server, but caching on the server as well. Because servers,
how would that help?
it wouldn't. It will only. It wouldn't. You're right. It wouldn't help. It wouldn't help in this conversation that we're having about latency, but it would help with the fact that because we go back to that chart also where you see the whole process. We actually have the why don't we go there? Yeah, this guy over here. It will help you with that orange bar. Whatever that bar. It will shrink it. But yes, caching, obviously it goes without saying. It goes without saying that all server, this is after all your server optimizations, right? We're talking about communication between the client and the server. But the actual request processing over here, yes, do all whatever, do all that stuff too. Okay, so that's the first step. That's the network. Let's move on. So we got everything down into the client, and now we have the critical rendering path. The critical rendering path is basically the browser has to now, it has all your assets, and now it has to get them up onto the screen. So there's rules that it follows in order to, in parsing your HTML and parsing your CSS and executing your JavaScript, there's a process that the browser follows, and that makes a very big difference as to when your pixels will actually get onto the screen. So we're going to talk about that now, and it's called the critical rendering path because it's critical to getting what? It's critical for rendering, and it's critical for your bottom line because if you spend an extra because you could mess something up in the way you structure your HTML, like we'll see in a second, that could cost you an extra 2-3 seconds, and your and your users are bouncing. So here's basically. Let's just look at what this process is. Everyone knows what the DOM and the CSS is, right? The DOM is basically document object model. It parses your HTML and it builds this tree structure with all your tags and whatnot. CSS is basically its cousin, which does the same thing for CSS. Puts them together to create the render tree. So you see over here, this span has a display none, so that span is just not going to be in the render tree. So the render tree is basically DOM plus this is DOM is the render tree. If something's not on your screen doesn't mean it's not on the DOM. It just means that it's not in the render tree because it could be your CSS took it out of the job. So to learn about all these rules, instead of me boring you to death, I'm boring myself. So this part is it's the only way to learn about this is to actually see code and to execute the code. So that's what we're going to do right now. So we're going to demonstrate all the different aspects of the critical rendering path in 15 minutes. So where are we going? Okay, ladies and gentlemen, welcome to Critical Park. And what's Critical Park? Critical Park is just basically a way. No, I don't want to. It's basically a park where we get to explore all the different parts of the critical rendering path and meditate on very important Velociraptor memes at the same time. Very important. So the first thing we're talking about is first page we're looking at is critical CSS. So this is critical CSS. Simple HTML file. Can you see it in the back? MOPT? Hi, Donnie. I can try to make it bigger. It's WebStorm. WebStorm doesn't like when you make things bigger. It doesn't like when you change things. Does it? Then it's gonna make everything weird. How do you do that?
Right, toggle presentation, right? Down.
Okay. Oh dear. Oh, that's so weird. Okay, we'll do it anyways. So what do we have over here? So we have pretty much HTML. Yeah, now you can see in the back? Yeah. Okay, good. All right. We have, right, HTML5, we got the head, we got the title, we got a style sheet. That's not what I meant to do. Let's do that. We got a style sheet, and we got basically H1. So CSS is, here's the first rule we're going to learn. CSS is render blocking, right? So let's load this. So basically, let's before don't look at the body yet. But basically, we have the style sheet now. This style sheet is getting from load CSS timeout 3 2000, which is basically just like it's an endpoint that I made that will to simulate latency because I'm on a local host, so there's no way to get latency. So I'm just going to tell the server, serve me the style sheet, but wait 3 seconds. Wait 300 milliseconds. Okay. So what's going to happen when we go to that page? So we went to the page and we are going to wait. We saw nothing for 3 seconds. Why? Because CSS is render blocking. The browser must wait for CSS to be fetched and parsed before it can paint anything to the screen, because otherwise you get a flash of unstyled content, you get a reflow, you get a replay. They're not good things. We're not going to explain exactly what each one. So CSS is render blocking, which means that when the HTML, when the parser gets to here, it has to. It says, okay, you told me that you're loading CSS. I will not paint anything to the screen until that CSS is loaded. It will parse the rest of the body, right? It will parse the rest of the body, but it's not going to load anything to the screen. If you look at the network panel, basically, right, it will load everything right away. It will load the image right away also. Here we go. Whatever. But that's critical CSS. So again, CSS is render blocking. What about JavaScript? What does JavaScript do for us? Okay, presentation mode. How do I see my how do I How do we get to my other files?
Right there.
What?
Shift, type the name.
That, you're taking for granted that I remember the name.
Alt 1.
Let's talk about, so CSS is, now we go back, and the presentation mode. Just say that.
VS Code.
VS Code, Alt 1. Oh, how you doing? Thank you. Okay, so here we have, our CSS file, which doesn't have a delay on it, right? No delay. We'll load it right away, but we have a JavaScript file. The JavaScript file will take 3,000, also take 3 seconds to load. So what's going to happen? Basically, it's going to be a similar effect, but it's going to be even worse. So here it's going to be the same. It's going to take the same 3 seconds, but the script execute. So we have to wait. It blocks the parser, meaning the parser is going to stop. It's not even going to parse this, right? CSS did parse the whole thing. It just said, okay, I'm not going to paint to the screen until I get my CSS. But if you have a script in the header, it will the parser will just say, okay, I'll wait. Keep waiting, right? Why? Because it's very simple. Right, the JavaScript could actually change the input stream using document.write, and hence the parser has to wait for the script to execute before continuing. If you spill cleaning product, did you make a mess? I'm not sure. So if you look at the performance tab, is anyone familiar with performance tab? No. Basically, performance tab, you can actually run a profile on what the actual parser and JavaScript renderer is doing. But if you see, we actually
You gotta do with
have to
clear it and refresh.
I have to clear it. Sorry. Let's try that one more time. No, it still didn't get it.
You should. I think you're getting.
No, I still have the screenshot. Okay, but the point is, if you look carefully over here, and don't freak out if you don't understand everything. But basically, if you look right over there, it's telling us that it only parsed lines 1 to 5. So it parsed HTML, but it only parsed lines 1 to 5. And then, like a long time later, guess how long? Like, very long. It's like, there he is. Like 3 seconds later, that's when we parse the rest of the file, line 6 and on. So the actual parser, the Chrome DevTools, please everybody learn it. It's the best thing you can do for yourself. Okay. Yeah. So you see, until like 300, until like 3,000 milliseconds in, it couldn't even parse. So so that's even worse. So what I do?
Oh, no. Well, the image won't be downloaded either, right?
No. So very good question. So until recently, that's a very good question. Shai wants to know, what about this guy over here? Will the image get downloaded? So it's very interesting. If you look in the network panel, you see, yeah, it does. Why is that? Because it used to not. But browsers got really awesome. I'm not joking. Probably the greatest performance optimization that the browsers have done for the world and for the good of mankind is to create something called a preload parser. There's basically 2 parsers going on at one time. One's actually parsing your HTML, and one is, they call it the look-ahead parser. Basically, it will just look ahead, and it will see it will look for scripts and images and style tags and all that stuff, and it will already start loading it. Even if the regular HTML parser didn't hit there yet.
Scripts also?
Scripts also. It will just it will shoot off all the requests. So if we're talking about performance, right? A lot of times you'll see this a lot with like analytics scripts. They tell you like, hey, just dump this in the header, right? A lot of times they like do they do the shtick where they'll use JavaScript to create the script element and append it to the body, and assign it to assign the source to a certain URL. You just hid the URL from the preloader, right? So that optimization went away when the browser. All modern browsers do this, not just Chrome. All modern browsers have a look-ahead parser. So to be very careful, make sure you're not hiding your resources from the parser, from the preloader. It's very important.
Even links, they could go ahead
Sorry?
even links at prefetch.
Yeah, so the prefetch also. Okay, so we want to talk about that. Also, there's other stuff that we'll get there at the end. I hope. But yes, the browsers have done even. How do we get to? Okay. Command 1. Where are we up to? Well, let's go back to here. Okay. So another thing that JavaScript does. JavaScript is awesome. JavaScript will actually, another thing, we're waiting 3 seconds. I waited like 1 second. I guess I must have said. If a tomato is a fruit, then it's ketchup a smoothie. How did that? Well, we discussed JavaScript blocking on CS. Now, JavaScript has another problem. Not only could it affect the input stream, the HTML, it also could query the CSS, the CSS whatever. So we need to create the CSS So we have a sort of a catch-22 here, and this happens. We found this in Quality Bath's code base recently. Okay, we have the DOM can't get parsed because there's JavaScript that's waiting for your CSS. Okay, it can happen, and I'll show it to you right here. It's parsed. Basically, we have a style sheet. Wrong one. Here we go. There we go. JavaScript will block on CSS. Basically, if you have a script file that's taking, see, it took a second because whatever, and then you have the JavaScript after. So the JavaScript, which is parser blocking, is now going to have to wait. Even though it will load instantly, it will still wait to execute until your CSS hits, until your CSS loads. So now you block your parser again, and this will happen even if it's in the footer. So that's that.
The CSS song can get created without the DOM?
It's a separate thing. It's a separate thing. So that's that. So it seems like yeah, but parsing is incremental. So if you look at this page, just another anecdote. While you're waiting for the waiter, you become the waiter. DOM parsing is incremental. So if you notice, if we refresh this page again, so first we have the top while it's loading, and then we had the image. So what happens? So if you look at the markup over here, if I can find it, parsing is incremental. So there we go. So we have a style sheet which is instant, and also in the middle of the body we were like pretty dumb. I don't know who wrote this code. Basically loaded a JavaScript that took 3 seconds to load. So basically up here we have the style sheet that loaded instantly. So the parsers parsed, the parser got to here, and it had the CSS, so it said, okay, I'm just going to render to this. I'm going to render to the screen right away. But then it hit the script that took 3 seconds to load, so then the parser stopped. But the browser was already painted to the screen. So it's just an important thing to know about the way browsers work. So over here, an optimization technique could be if your server is like flushing HTML, in chunks. If you don't have any blocking scripts, you can actually start loading. Even if you have a blocking script somewhere down the page, you can already start painting to the screen right away. And Google does this on their search page. They just flush the header right away with no JavaScript whatsoever before they even go to the database with your search query. So yeah, Google knows a thing or two about performance. So that's basically that. So any questions? All right, so remember the old CSS at the top, JS at the bottom rule. It's like one of the oldest rules in the book. Put your CSS at the top and JavaScript at the bottom. Now you know why, right? Now this doesn't always work for you because, like we saw, it still blocks. You still get that spinny. JavaScript is not our friend. It is our friend. We love JavaScript. Here at Quality Bath, we are religiously JavaScript. But as you can see, it blocks the parser and it's really problematic. So what can we do about it? And sometimes you need JavaScript higher on the page. It doesn't always work to have it on the bottom. So, async defer to the rescue. We'll try to do this quickly because we're what's it called? What is async and defer? Async defer are new attributes that were added recently. Thank you, Microsoft, because they actually did something good for the world by adding defer, and then afterwards everyone else came along with async. But basically, here's a normal JavaScript execution, like we said. It will parse, and then the gray is like no parsing. No parsing. We'll fetch, we'll execute, and then we'll continue parsing. Async will fetch it asynchronously, then it will stop parsing. As soon as it gets it, it will execute it, and then it will continue chunking. Defer will defer the execution. It will load it asynchronously, but it will defer the execution until after the DOM is finished. Before the load event, but after the DOM content loaded event. So that's async and defer. If you want to just see that quickly.
Does that work for CSS also?
No. No, they're working on it. They are working on it. They as in like the elders of the internet.
Abby?
What? Abby? No, your voice, I think, in
It's not a question. You can do it to Josh.
Right.
right. Yeah. And he's Mr. JavaScript.
Unless the JavaScript is. Right. Right.
So here's async. So whoa, we loaded right away, but we're spinning, and now 3 seconds later, right? If I download a movie in Jamaica, am I a pirate of the Caribbean? So basically, where's the there we go. Async. So basically, no, absolutely not. There we go. So here it took us a second to load. We have async, and so everything it loaded right away. But async, right? The async tag is basically telling the browser. I think I have this on the screen also, right? Async tag is basically telling the browser, I promise you, I won't use document.write. So the browser says, okay, I trust you, and I'm just gonna run, and I'm gonna run the page. Defer does the same thing.
What's the matter with this over putting JavaScript on the back?
So good question. So okay.
The mile is that it could be on the top.
The mile is that it could be on top. Sometimes you want it on top. Sometimes you want it.
So that it could start again.
Downloading
it could
first.
Start downloading.
Start downloading. Yeah.
That's the real answer. Right. You want to start that. You want your assets to be as close to the top as possible. Even though you want your JavaScript on the box, you don't want to block the parser. JavaScript on the bottom, you don't want to block the
Here's
parser.
another distinction with async.
What did you say?
That it'll
Oh yes,
execute.
I'm sorry. Very important. So Mr. Tukutsky reminded me. Let's say we have this guy over here. Let's say we have 2 script tags. We have JS2. I'm a little new at Vim, so sometimes things take a little longer. But let's say you have 2 scripts, right? And the second one will load faster than the next one. And let's say our JavaScript. Not my colors. So f2.js. So let's say we're going to load 2. So if you look at the console, I'll find my thingy. Look at my console. So spinning. F2 came before F1. Executed before. Why did it execute before? Because it landed quicker.
And what'd you
The
do?
main point is
All
that
I did
it
is
wasn't
the
async.
point is I lost the order. Even though JS, this guy was listed before this one executed first because it landed first. It doesn't maintain order.
So if you have
As-
dependencies, then you're
Oh,
using.
so what do you do if you have dependencies? So you do this.
Does defer help with that?
So defer maintains order. That's the order. So that's where defer is going to be. So change this guy to defer. So now, and refresh this page. So now we'll actually wait a full 3 seconds, and then we'll execute both at the same time. So if order is important, you have to use defer. And I think what? I
Original
spoke about
smart
defer. So basically, you optimize the critical rendering path, right? Just for a quick review, CSS is render blocking, JavaScript is parser blocking, and also JavaScript will block on CSS. Therefore, get CSS down as fast as possible if you want to paint your picture to the screen. CSS without JavaScript at the bottom. Obviously, use async defer. If you need to have your JavaScript at the top, and you do want to have your JavaScript at the top because you want the browser to start loading it right away. And just think about, do you really need JavaScript in your critical rendering path? Just saying. Any questions? Why not use inline
Why
CSS?
do you inline CSS?
Why do you? You could do that. You lose caching. You should. So critical CSS. So that is an optimization technique that people do. Is you'll on the server you'll figure out exactly what your critical CSS is. You'll inline that and then load all your other CSS. The problem with inlining all your CSS is that you lose all your caching. And like we spoke about at the beginning, so you'll end up you'll bloat your HTML, and if anything in the HTML changes, that cache will be invalidated, and you
So you could look, if you put your CSS on the bottom, then you could download inline CSS and the style sheet being loaded. So will you get a flash then?
Yeah, because the parser will still because the parser will still see the no. Oh, it depends. Okay, I didn't understand what you're asking. So what? So Shai is asking what happens if you have your inline CSS on top and then you have the CSS further down in the body.
Yeah.
So it's Machlekes browsers, but some browsers will will see it. Well, the preload scanner will see it, and then it will say like, oh, there's a script later on. Other browsers will render everything till there, and then continue once that loads.
If you want to do that, you would better best off dynamically inserting. The
Right,
CSS
right. If
down.
you want,
So
yes.
whatever.
So if you want it dynamically loaded, so there's the guide by the Filming group. Right, these guys. Oh, look at this. I've seen it before. So this guy, a function for loading CSS AC, but that's what you use for that. Okay, just some resources before we end. So there's Hive or Verbans that were. So everything we spoke about in the first half is this guy, Eli Golding, wrote a book called High Performance Browser Networking. It's put out by O'Reilly. Amazing book. We'll go through everything that we discussed before about bandwidth and latency, TCP and TCP, TLS. We'll talk about the way mobile networks work and the way cell phone towers and all that fun stuff. So that's that. For critical CSS, just some tools, right? So if you want to start ordering your sites, so you need tools, right? Because if you can't measure, you can't. If you can't measure, then you can't fix it. You can't optimize what you can't measure. So Chrome DevTools is amazing. DevTools is, of course, it costs money, but it's really awesome by this guy Umar Hansa. There we go, Umar Hansa. He has a paid course and he also has a lot of free material and stuff like that. But I just started me and Shai just started working through this course together. It's really amazing. You learn everything about DevTools. If you don't want to pay,
Come work for Quality Bath.
What do you say?
So come work for
Come
Quality
work for
Bath.
Quality Bath, and we'll give you the password. What else is there? So Udacity has a bunch of courses free from Google, from actually Eli Golding himself, who wrote that book, has
Yeah, that one.
basically, it's basically, of course, I obviously did this already, so it's not showing the description. But basically, there's courses on Udacity, on the correct rendering path, and also on the actual way the browser re-renders, and to avoid jank and stuff like that, which is something that we didn't get to. We'll get to a different time. One last thing that I didn't talk about is images. Images is a whole talk within itself. But if you're going to walk away from here tonight thinking that I forgot about it, I didn't forget about it. But that's like a whole other schmooze, is images. Images make up 60% of the web content. And if you're not serving the right images, if you're not serving the right size images, if you're not serving them at the right time, you're killing your websites. Okay? Well, trust me. Trust me, we know. Okay? So image optimization is huge, and maybe hopefully we'll get together to talk about that again at a different time. But in the meantime, that's my talk. Thank you so much for coming.